Okay, cool beans. Let's have a look at probability trees. All right, so why do probability trees in the first place? So sometimes probability can be a bit tricky, right? So working out probability for individual events is pretty straightforward, right? You toss a coin, it's 50-50. We know that straight off the bat. But the problem comes in when we start looking at what happens if I flip the coin 5 times and I want to know the probability of it landing on heads every single time. Right, then we need to know whether do we multiply them or do we add them, and this can become quite tricky. Okay, so how do we know when to multiply our probabilities or add them? Okay, when we in doubt about this, we draw a probability tree. Okay, cool. And they make your life a lot easier. Okay, cool. So let's use the one that we all know and hopefully love. That's tossing a coin. Okay, cool. So we have 2 possible outcomes, right? One of them, so 2 possible outcomes. Okay, one of them it's going to land on heads, and the other one it's going to land on tails. Okay, cool. So my probability is 50% or 50%. Okay, each way, half and half. Okay, cool. One thing to remember when doing probability is that we don't want to write it in percent, we want to write it in a decimal. So we're always going to divide by 100. So our probability is 0.5. Okay, if they ask for what's the percentage or whatever that you play, then we will have to times our probability by 100. But we always work with decimals. Okay, so if you get a percentage, convert it to a decimal by dividing by 100. Okay, sweet. So let's say that we toss the coin 3 times. Okay, so we toss the coin 3 times. All right, so we're going to draw a probability tree. So we start off with our 2 possible outcomes. All right, so first we have heads. Right, it can land on heads, and second it can land on tails. We write the probability of which on the line leading to it. Okay, so it's a 50-50% chance. Okay, then we're going to toss the coin again. So we have another 2 outcomes. It lands on heads and it lands on tails. And the same goes here. So if the first time it landed on heads, right, then we have these 2 guys probable. But if it landed on tails for the first time, then we have another shot of landing on heads and it landing on tails again. Okay, and it's still 50% chance, right? The coin never changes. It's not dependent on anything. It's completely independent. So this is what we call an independent event. Okay, and then lastly we flip it again, and each one of these guys gets a heads and gets a tails. All right, gets a heads and gets a tails, and each time we write in the probability. 0.5, 0.5, and heads and tails. Yeah, you see it quickly gets tedious, but it does help. Okay, and make sure you give yourself enough space, because even now, which I thought I gave myself plenty of space, it's still a bit cramped. So when you're writing your tests and stuff, just give yourself as much space as possible. 0.5 and 0.5. Okay, cool beans. So now I'll ask you, what is the chance of it landing? What is the probability? All right, so question A, what is the probability of it landing on heads 3 times in a row? Right, so what we do is we follow the trail that gives us heads, heads, and heads. So we go this guy here to that guy and then to that guy there. Okay, and what we do whenever we're moving across, so when we're moving across a probability, so if we're moving like horizontally like this, we multiply our probabilities. So multiply probabilities. Okay, so we have 0,5 times 0,5 times 0,5. So for A, we have 0,5 times 0,5 times 0,5. So the probability is going to be 0.5 times 0.5 times 0.5 gives me 0,125. Okay, let's say we had the probability of it landing on so B, let's say landing on tails, then heads, then tails. Okay, so what we do, we follow the line that gives us tails, right? Then we said heads, then we said tails again. Alright, so because these are all independent events, we're going to see that it all equals to be the same amount. Sorry, give me 2 seconds here while I sort out my pens. So we multiply, we're moving across the probability table, so we multiply probability 0,5, 0,5 times 0,5, and that gives me the probability of that happening is 0,125. Okay, and I'll find that all of these, the probability of all of them gives me 0,125. That equals 0,125. That equals 0,125, and so on. And if I add them all up going down, right, I should end up with 1. So if I add all of these 0,125s up, that equals 0,125. That equals 0,125. So 0,125, 1, 2, 3, 4, 5, 6, 7, 8 times. Yeah, 0,125 times 8 gives me 1. So if it gives you 1, you know you're right. If you don't get 1, then you've done something a bit wrong. Okay, so that one was straightforward because it's everything is, it's an independent event, right? So every possible outcome gives us the same answer. So let's have a look at something where it's not independent, where we have a dependence on something else. So we have a change in our probability tree. Okay, so this is a question. All right, so you play goalkeeper for a soccer team. All right, there are 2 coaches. One of them is Sam, and he coaches 6 out of 10 games, while Mary coaches the rest of the games. Okay, Coach Sam selects you for the team half of the time, and Coach Mary selects you 3 out of 10 times. So what are the chances of you playing today? Okay, so there's quite a bit of information there. So first steps first, we write down the information in a way that's kind of a lot easier to understand. All right, so let's have a look. Okay, so firstly, there's 2 coaches. All right, there's 2 coaches. One of them, Sam, coaches 6 out of 10 games. Okay, so we have 2 coaches. 2 coaches. Okay, so one of them, Sam, right? So the first coach is Sam. He coaches 6 out of 10 games. Okay, so he coaches 6 out of 10 games, right? So the probability of that is 0,6. Okay, then the second coach is Mary, and he coaches the rest, right? So obviously then if Coach Sam coaches 6 out of 10, Mary must coach the rest, which is 4 out of 10. So there's a 0,4% chance of him coaching. Okay, and now it says that Coach Sam selects you for the team half the time. Okay, so depending on which coach we get is going to give us, we're going to be selected a different amount of time, right? So it's dependent on who coaches us. So Coach Sam selects us half the time, right? And Coach Mary selects us 3 out of 10 times. Okay, so we have chances of being selected from Coach Sam, right? If we get selected for we have a 50% chance of getting selected, right? So if he selects us, let's just call that yes, we're playing, and 0.5% no, we're not playing. Okay, Coach Mary, he only selects us 3 out of 10 times, right? So I don't know, doesn't like us or whatever. All right, so 3 out of 10 yes, we're playing, and 7 out of 10 no, we're not playing. Okay, cool. So let's set up a probability tree. So they're asking what are the chances of us playing today. So we don't know who's going to coach us. All right. So we get there on the day, and we're either going to get coached by Sam, or we're going to get coached by Mary. And then we write the probabilities of which on these things. So Coach Sam coaches 6 out of 10 times, and Mary coaches 4 out of 10 times. Okay, cool beans. So this is who's coaching, right? So who coaches on the day. We don't know that, so we work out the probability. Now we have to see if we're going to actually play today. We don't know, right? So if Coach Sam is there, we get put in the team. So let's say that's yes and or no, right? This for Sam, it's a 50-50 shot. For Mary, on the other hand, he either lets us play or he doesn't, but it's a 0.3% chance that we are going to play and a 0.7% chance that we're not going to play. Okay, so that's our information. So this line here is, are we playing? Okay, so the question was, what are the chances of us playing? So there's 2 possible outcomes out of a total of 4 that we are going to play. Okay, so we're looking for the ones that end in a yes. All right, yes, we are playing. So we're going to follow the pathway that leads us to here and leads us to yes. So firstly, if Sam's coaching, right, we have this one to get a yes, right? And if Mary's coaching, we have that one to get a yes. Okay, so remember, when moving across, when moving across a probability tree, we multiply. All right, so to find out the chances, the probability that Sam's going to coach and I'm going to get a yes, so the probability of Sam coaching and a yes is Sam is 0.6 and giving us a yes is 0.5. So I go 0.6 times 0.5, which gives me 0.5 times 0.6, which gives me a 0.3 probability of playing. So in other words, a 30% chance of playing. So you see the difference between probability and chance. So probability is a 0.3. That's your probability ratio. But we have a 30% chance. Okay, so just know that difference. Okay, the other one is if Mary's coaches, right? So we have if Mary is coaching and he says, yes, we're going to play. So Mary coaches 0.4 and he says yes to us 0.3. So we have 0.4 times 0.3, which gives us a 0.12 probability. Okay, which is a 12% chance. So I just times that by 100 to get my chance. Okay, so that's the individual things of if Sam coaches and if Mary coaches, right? But there's 2 outcomes that we get is what we want, right? We want to know if we're playing. So we're going to then add up going downwards. So going down, we add. Okay, so we had Sam saying yes to us, okay, it was a 0.3% chance, and Mary saying yes was a 0.12% chance. So the total probability of us playing that day is 0.3 plus 0.12, which gives me 0.42. All right, so we have a 42% chance of playing today. Okay, cool. I hope that clarified some stuff. Just remember, moving across to the right is a multiplication, and moving down is we're going to add up, right? So we added them up because we had two outcomes that suited us, right? That we wanted to get. We wanted a yes and a yes, so we had two lines. So we added up the two possible probabilities. All right, if we had three of them, we'd add up the three. Okay, so we look for our total possibilities here. Okay, yeah. All right, let's just say, for example, just to clarify that, I wanted to know what probability would it be. So we're back at the tossing a coin. So I'm just trying to very carefully remove those highlighters so we can actually get in what we want. So I want to know what the probability of rolling two tails, okay, of tossing for two tails. Okay, so we need pen. There we go. This is getting confusing. Okay, cool. So we want to know the probability of two tails. So we've set up our diagram already, right? Our tree diagram. So we're going to look for all the ones that have only two tails in it. So it's obviously not the first one. Heads, heads, heads. No. Okay, we look at the second one. Heads, heads, tails. That's only one tails. We look at the third. Heads, tails, heads. That's still only one tails. And we go heads, tails, tails. Cool, got one. So we have this guy. Okay, let's look at our fifth option. We go to tails first, then we get heads, heads. So not that one, right? Or we go tails, we go head, and then tails again. So that's two tails. Or we can have this one here is tails, tails, and then heads, because that gives us two tails, right? So over here, if we wanted to know the probability of getting two tails, right? Two tails. We work out the probability of each one of these things going across, which is 0.25. So we're timesing it, 0.25, we're timesing going across and timesing going across. Okay, so we've got three outcomes that suit us, so we're going to add them together. So we get 0.125 plus 0.125 plus 0.125. And that gives me 0.125. So 0.375. So that's our probability. If we want a chance, we'd times it by 100, and that would get a percentage. So that's chance, and remember, our decimal is probability. Okay, cool. So I hope that makes a bit more sense. Remember, moving across it, we times, and moving down, we add. Okay, that's it for today.